this particular example, we're going to look at exercise 32 example that is provided. And again, they give you hand calculations. You may very well like to try some of these hand calculations because they calculate the standard error. Standard error is just a modification of the standard deviation that is used for samples. It's the standard deviation divided by the square root of n. You may very well want to try those. The table provided is the participant numbers in table 32-1. The difference of the scores, we don't need if we're using SPSS. You do if you're using the table itself, but you don't need them if you're using SPSS. So the only thing that I put into this data is participant number. And again, I made all these decimals 0 because they're all just whole numbers. And the baseline depth and then the post-treatment depth. Those last two are scale variables. The first one is an ordinal variable. And I put the data in, and again, it was just the first three columns out of table 32-1. The difference between the two is calculated that I need if I'm going to do this by hand. Understand something. When you're dealing with this particular kind, this is what's called a paired dependent samples, because in reality, we have the same participant with a baseline and a post-treatment. So while I have two groups of data, they're paired. They don't come from different sources. So the baseline, participant 1 produced baseline and produced the post-treatment. So it's almost like having a single sample because I'm going to combine the two together. And so what you're going to do for this particular one, you're going to use the analysis again, but this time we're going to use compared means, but we're using the one for paired sample t-test, not the independent. Okay. And here we're going to, the pairs are the baseline is the first one and the post-treatment is the second variable that we're using. Okay. And then we're going to say, okay. And so the output is we get the mean of the individual groups, okay, samples. We get the individual groups. These are the two different variables, the baseline and that. There's 10 of each of those, and the standard deviation for each of those. And then we have the paired correlation, which is, let's see, let me go back up here. Okay, so we have that. And then we have the independent sample itself. And again, we have a value here. Paired sample correlation. Where did that go? Down here. So this is down here, the paired sample correlation. We have the mean and the standard, and then we have the paired sample correlation. This is what the 0.816 is what's called the correlation coefficient, which we'll talk further on some of the other assignments. And then here is our sample, our t-test. And remember, for our t-test, our key points are the test statistic. In this case, is 10.585, quite large. And that will produce a p-value of very, very close to 0, and so they show it as basically 0. So it's less than 0.0001, and that's what causes it to show up there as 0. So again, we're looking at, we compare that number to our alpha, which is our risk of making a mistake by rejecting the null when indeed it really is true. And in this particular case, we would reject it because we have such significant values. Thank you. I hope this helped you to set up your assignment for this week.